if I could ask someone to just watch the chat. I'll try to keep my eye on the other screen here. But if we go to our schedule on here, and I'll just drop the link for this in the chat. Want to click and follow along. There we go. Hi, Sophie. Okay, so first let's look at the schedule here. Let me see, I'm not sharing my screen. Let's share my screen. There we go. We just look at the schedule. For the next few meetings, I'll just make this a bit bigger for everyone. It's okay. Next week, we'll continue reading the Plant 2019 book, and we'll go to Chapter 2. Chapter 2 is a meaty one, so if you're interested in this and want to follow along, we have gone through the first couple of chapters before, but we did it very quickly. We'll continue that. Following week, no meeting that week. The week after that, we'll pick up natural language processing, the second session. There'll be about, I estimate, around 9 or so sessions for this from beginning to end. And then a couple of weeks of no meetings while some of us are traveling to South Africa. Okay, so today we're on the Bootcamp launch. Now this is, I put this as kind of as a joke as season 2, but it really is the 3rd or 4th time we've gone through the Bootcamp over a number of years, and the Bootcamp has evolved. If we just have a look at the Bootcamp page, most of you have seen it. I'll just drop a link in the chat. Now, I created this material for a number of reasons. I created this material to be a resource that was open and accessible to PhD students, to data scientists coming in to study on the Master's in Data Science course who didn't have a background in programming and stats. And then I began a few years ago, as some of you know, using it as a resource for all the other MSc programs to, because we had a set of best practice guidelines for using a scripting language for reproducible research, and specifically R, but also to reach the generalized linear model and the generalized linear mixed model level of material. I started offering the Bootcamp as a way to break the shock of doing that intensive 1-week module in general statistics in the experimental design and analysis module. So I've used it for a number of reasons, and there will be a change next year. I'm fairly happy with the scope of the material, and I'm fairly happy with the website and the way the tutorials run, but I'm not happy with the level of self-assessment, which is within the spirit of the stats bootcamp. This should be a self-contained, self-guided with assessment and everything built in, and the assessment is a weak point. So part of going through it early this term is for us to critically examine the self-assessment material, and I would like some feedback. And after today, in future sessions, there'll be some room for participation, even if you are an old timer and already use R quite a lot. Let's just go back to our schedule page. And I'm going to go through a couple of sets of slides, an overview set of slides. Now, I hope they work from here on this link. Let's just see if they do. Yeah, I didn't think they would. I think there's an issue with GitHub rendering this HTML page. So don't follow along on that link. I'll just open up a local copy on my computer. And I'm going to go through the brief slides, and then we're going to dive right in with practical and follow along on the Bootcamp page with the exercises for the very first page. We should be able to easily do all of that in this time. Any comments or questions before we dive in? I'm just going to unshare my screen for a moment while I navigate the dark depths of my computer. Open the slides. It's looking okay. Seems to work okay. Here I come sharing. Just there we go. Been using a new framework for slides and for the website, and actually for quite a lot of other things in my own professional practice of stats and the way that I communicate with my own students and those of others. And that is using the language Quarto that has recently been implemented in our studio. We have done a session or two on Quarto. One of the things I really like about it is the automated slide facilities. And it has this little slide out menu that's automatically done. And I just wanted to remind myself of what the full screen hotkey is for our recording today. So I'm going to go full screen. There we are. So this is day one of the RStats Bootcamp. This set of slides is to introduce what the spirit and philosophy and learning objectives are for what I call the RStats Bootcamp. I have already pasted the URL into the chat. You can reach it right here. This is a GitHub website. The RStats Bootcamp is itself a GitHub organization owned by myself. And I don't mean owned in the material sense. I mean owned in the technical sense that GitHub requires a single person with a GitHub account to own, in air quotes, all organizations. So this is just basically my website. Now, what is it all about? Really, I created this to introduce the idea of combining together the modern standard for best practice for statistical analysis. And, you know, for almost everybody, this includes that statistical knowledge, just enough computer science and coding to get the job done, and of course, subject knowledge for the subject of the data that we're analyzing. Really, I haven't ever given a whole session on this, but my philosophy very strongly in science and in applied data science is that we should think about data as a vehicle to pair up claims we may make. Now, the claims may be scientific hypotheses or proof of practice with evidence, and we use the statistical framework to produce that evidence. What's the boot camp part? Well, I want to say this in a very clear way that some people have commented that boot camp sounds kind of hardcore, and you know, the traditional idea of it is that it's difficult, unpleasant, not very friendly, hierarchical, you know, and the weak will not finish. But that is definitely not the view of the boot camp that I've created. Instead, it's something where we come together. We start doing something together, and we can help each other do something good. Now, a very important part of the boot camp is this self-guided part. Okay. I'm often asked if we can go through the boot camp material, if we can revisit the boot camp material. And we can, is the short answer. But I've created this to be a self-guided resource so that you can dip in as and when and as often as needed. And there is just a practical limit to how many times we can reiterate it over and over. And so I've taken quite a lot of pains to design the material to be a self-guided resource. But having said that, most of what I want to get out of these sessions is to illustrate how I intend the material to be used as a self-guided resource. So to get the most out of it, you will have to follow along and do a little work on your own, but I'm happy to do this together for another season. Okay, so the idea is to learn skills in basic statistics and R scripting from a standing start, or to refresh skills that are rusty, or to take your existing stats knowledge and start using R as a tool. Thing that I would like to say to my colleagues, if there are any in the chat, there are some, I can see some, and students who I view my personal philosophy also as colleagues, is that there is no better framework these days to have that framework of evidence and claims for within a statistical framework than R, and as such, it's a fantastic tool for assessment if you're a teacher, or for collaboration if you're all the rest of us. Okay, so by boosting these skills, even if you know R and can practice them, whether you're learning for the first time or whether you already have some skills and you're going to take part in this to help and shepherd other people, it's going to boost your success. And that is really an important part of this. And another, primary tenet that I've used to design this material is that anybody can do it with no prior knowledge. So it should be accessible to everyone. Now, who is it for? Well, I've mostly said this, but to be explicit, it's for students in the applied sciences. Okay, I don't mean this material isn't really appropriate for mathematical statisticians, but I mean it for applied scientists. It's also for what we might call data scientists who aspire to take on coding skills, best practice, and statistical skills in particular. Data scientists often are trained primarily in computer science and programming without a lot of experience in that claims and evidence framework. Okay, so it's for them as well. If I could reach out to one community who are very eager often to learn R, it would be my academic colleagues. There's a great desire amongst many of them to learn and use R. Of course, time is a barrier, and it will never be a better time in your career than right now. And a message that I have for them and for my colleagues who happen to be students, and some of you may be both supervisors and students, is that the R framework, when you begin using it with any collaborator, makes your job much easier instantly. Rather than viewing it as something you have to learn and constantly struggle with before you can get anywhere, instead, it provides a foundation that you can use to collaborate with, literally, explicitly collaborate on documenting an analysis. And also, if you find that you need to collaborate with for example, professional statistician, it is the easiest and fastest way to do that. Not only that, it documents your analysis, and you can use it as a template for any future analysis. So it's a fantastic tool and will reduce your work. I strongly believe that even if you have to learn R and are still working on statistics skills, this will reduce your workload when you collaborate with other researchers and with your own students. Have my eye a lot on postgraduate researchers, especially master's and PhD students. But really, I aim this at anyone who wants to learn from data. Best practices. Okay, so this is what the learning objectives, as we might say, are. This is a very tall view of the learning objectives, and we'll look at a little more detail as well in a second. So we're going to learn about the R scripting language. how to do, I say the basics, but once you have the basics, you will have the tool set to do advanced statistics as well. In the bootcamp itself, we'll review basic statistics. By basic statistics, I mean statistics that have been around for about 100 years within the null hypothesis testing framework. Tools like correlation, simple linear regression with one predictor, analysis of variance, and some non-parametric tests. Current best practice for all research is reproducible research, where our data are open and our methods are open source and open in the sense that they're available just like the text of a peer-reviewed manuscript is. Some few journals require this now. More will require it in the future. Many journals suggest that you deposit your script, often R scripts, as appendix, as accessory or supplementary material. Finally, we're going to learn about something called tidy data, which is just a data curation technique. It's very easy to implement. We just have to learn about it and start practicing it. Okay, that's a high-level view. The organization is like this. I made a new website about 4 months ago. Most of you noticed. Really, the first 2 modules are for most people. The first module focusing on R scripting and the RStudio interface and the tools that does. We're going to learn about a little bit of scripting concepts by example with some data. Second module uses the scripting tools that we learn and applies them to simple data analysis, including graphing and data interpretation and reporting to a scientific standard of best practice. There is a third module, which I don't have live on the new website, but some of you have seen it. I think many of you have seen it and gone through it. And it's an introduction to reproducible code, where by reproducible code, here we extend the best practice that we do in module 1 and 2 to a tool called R Markdown. Okay, this is a way to embed live statistical analysis code within a framework that lets you report it to other people who needn't ever see the code. So it's a way to prepare reports. You can write academic papers in R Markdown. The version of R Markdown, one of the reasons I haven't made this live on the new website is that R Markdown has undergone an evolution and has been reborn in the language Quarto. So I need to translate the old material into the new language. And then finally, GitHub, one that we've talked a lot about in these meetings. It's a fantastic way to document your code for free. Okay. So there's 6 pages in module 1. We're going to go through them all. And as I mentioned, this is mostly about the R language, but we'll also introduce tidy data and data objects in this first module. Today, we're going to go through the setup and intro after this overview. The second module is the basic stats, where we go through some data exploration and learn some tips and tricks. Learn to explore the most common distributions that you'll encounter: correlation, regression, t-test, and ANOVA. Then the final module has 3 pages where we look at the reproducible coding in a bit more detail, look at report automation, and then finally Git and version control tools. One of the last things I want to say in this intro is that, and I think this is a place where I would like some feedback over the coming weeks, is that I don't think that the website of itself, if it is only consumed as a website passively, worst on a mobile device, it just doesn't function as intended. So it is intended that every line of code is run on the page and that the exercise questions are formally answered. I guess aside from that, if you familiarize yourself by actually running the code, what you're able then to do is have a bit of muscle memory and use the boot camp with no extra effort of yourself as a way to have a template or a reference or a wiki for commonly used bits of script and analysis. Okay, now I believe that's the last slide. And so the next thing that I would like to do is to just dive right in and look at the first page. I'm going to go open up the HTML page, but before I start the slide, just hopefully that opens up. We'll give it a moment to compile locally. There it is. Good. I just wanted to look at the page one. I'm just going to make this a bit bigger and point out a few features of the website. One, it's got a few accessibility features that I built in. You can use dark mode or light mode if you need a high contrast or prefer a high contrast. I do prefer a high contrast background myself, but for the recording, I'll leave it light for now. There's a search function. So if you go through the pages and you would like to refer back, but you can't remember what page, but you have any information about it, you can access every web page in the whole website through the search bar. You know, an example is maybe you've used the aggregate function, and you can just type it in and we get a list of options of places where the word aggregate turns up on the web pages. So it turns up on page 6, page 7, and page 12. Then another feature I guess I would point out is for every page, and if I just click on the first module page, on the right-hand side there is a clickable index that allows you to navigate through that page step by step. And more or less, the organization of the pages are the same to the best of my ability, where we start off with an introduction to what the page is about and the objectives, and each of the subsequent steps are usually exactly the objectives that are stated. And at the end of every page are some practice exercises, which we'll come to today directly. So what I'm going to do is, before we look at the page, I'm going to give the the introductory slides to the page, and I will in the future invite you to go ahead and have a look at each of the bootcamp pages beforehand, before these meetings, and your task will be to run the code that is offered to you on these pages before you attend, and then we'll have a lecture and have some time and problem solving for the exercises. Have some exercises at the bottom of every page because this is just the setup. There are still some exercises at the end of this page. Most of them involve coding in the subsequent pages. And in future sessions, we'll both solve the exercises and we will, on most of the pages, I invite you to write your own problems. So we will do that in future sessions during the session. But in the meantime, let's talk about what's in today's page. Now, this is set up an intro, and remember this is a standing start for students, but I'll talk through this in my own words, what the contents of the page are. So we're imagining, for some people, R is not installed, and even if it is installed, if it was installed more than 4 or 6 months ago, it's still probably wise to update your installation now. And I'll maybe mention a few reasons why I think that is in a moment. So again, the URL for the page and the introduction shows your first day with R with a picture of this gentleman, R.A. Fisher, father of modern statistics. This particular image was made by my daughter, who is interested in art, So a pop Andy Warhol style of R.A. Fisher. But he's well known, and I view him as important from the first day because his philosophy as a scientist, and he was a biologist and a statistician, and he is famous for discoveries in biology. For example, he described the mathematical foundation of natural selection based on genetics for the first time. But he's also famous as a statistician. He formalized the framework for the t-test, and he formalized the statistical test that underlies the analysis of variance. He invented maximum likelihood, and he supported as a colleague many other famous statisticians of the day who were also applied biologists like he was. But the spirit of the boot camp is that we want to do something good and immediately share it to others. And that is how I think of R.A. Fisher, the greatest statistician. Okay, so here's what we do. We're going to just, in my own words, say how the boot camp works. I'm going to say the briefest of things about why R. Why do we use R? Why is it so good? Why is it so popular these days? I'm going to talk about some options for using R, either a standard installation or I'll say a few words about RStudio Cloud if you haven't heard of it or used it before. We'll go through a brief overview of RStudio itself. I want to demonstrate to you, probably we'll take a time and look at RStudio, and I'll explain to you the setup for a standard R script best practice. And then there are a few exercises which will be brief for today's session. So I have emphasized this about how the RStats Bootcamp works. It's completely open, no login, no heavy-handed attributions, nothing. It's completely open. And in fact, I've taken some pains to remove elements of my personality from the material. I want it to be generic material. I would love it if people took it and did other things with it. I want it to be completely open. It's how I like to work. I want it to be self-guided. I've emphasized this, but I will elaborate on this as we go forward in future weeks. Thing I haven't mentioned yet is our Slack community. Probably most of you are aware of it who are in here, but remember this is geared for a very general audience, many of which might not be already in the Slack community. So this is just a link to our Slack workspace with all the different Slack channels for some modules that I teach, and also for the R user community here at Harper. And there are some people who have left and still come back, and some people that we've invited from outside the Harper community that also participate occasionally. Why R? Now, I could spend a long time talking about why R, but the briefest of reasons is that it was designed from the ground up for beginners. This is it was designed by some serious statistical programmers who were helping their colleagues, biologists. They actually worked at a research foundation, research and development arm of Bell Enterprises called Bell Labs. And to help their colleagues, they designed an open computing language that automatically calculated many statistical tests, and they immediately shared it for free with everybody they could. And their design principle from the very beginning was, we don't want to do this for programmers. Programmers can already do this. We want to do it for non-programmers. And R is, to my knowledge, one of the very easiest scripting languages out there for any scripting language. And for statistical scripting languages, it's definitely the easiest. Now, why are we going to all this trouble with statistical scripting languages rather than just an out-of-the-box point-and-click language? Well, best practice dictates that we have reproducible analysis. So this is a strong motivation that we need a scripting language, and then there is this this design for beginners motivation. Mentioned several times that scripting languages are best practice. Why is that? Well, to perform an analysis with a scripting language, you have to write the script. And best practice is that you document that script and make it available to others in addition to your results. Now, this, for many years in scientific papers, this hasn't been the case, but it's been rapidly changing over the past 2 decades. Some journals I mentioned before require open, reproducible analyses and open data, but they're rare. It's rare to actually require that for publication at the moment. But many, many journals now view it as an element of best practice. So we will treat it as such. And a big motivation for it is not only is our the best tool for best practice in statistical analysis, it's open source and it's free. Astonishing. It was created by scientists for scientists and immediately communicated for free. That is the best tradition in science ever. I could say a lot more about why we choose R. One thing that I might go back and add to this that's very important, I think, is the fact that, let's see if I can write on this. No, I can't. Is the fact that there's a huge community. It's very popular to use R these days, and people all over the world in many countries use it. And another thing that I would mention for most people, this would be a huge bonus, especially for students, is that it still, at this point in time, is impressive if you can use R on your CV. Many of us would look at your CV, and if you say that you have some proficiency, even as a learner in R, at least that's something that you can start with. As opposed to point-and-click software, there was a time, I would say it's about 40 years ago now, so quite a long time ago, when just using a computer was something that would go on your CV. Maybe 30 years ago, using Microsoft Word, that goes on the CV. Maybe 20 years ago, SPSS, I'm really good at it, on your CV. But when everybody has the basic use of tools like that, it ceases to be an advantage. R is a big advantage. And this is a special message to supervisors of students that even if you are proficient in another piece of software, it's your duty to think of your students and not merely thinking of yourself. You have to arm your students with best practice tools as they come along. So this is also the spirit of the boot camp. Okay, so I'm going to take it for granted that most people probably in this meeting have installed R and R Studio, but there are 2 options that that I'll just briefly mention. I have links here that are live in the slides. I'll have to fix the slide links after today's meeting, but you can download and install R from CRAN. There are 4 official updates per year, most years. We're at the moment on version 4.2.2. The best practice, the easiest practice, I should say, is to install R first and then download and install the latest version of RStudio Desktop, which is an interface to R. RStudio doesn't make any calculations on its own. It just uses an interface for R, and it has a lot of utility tools that are just convenient for us. It's made by a company. The company used to be called RStudio, but they have recently changed their name to Posit. RStudio Desktop is free and open source. It's open and free to use for science and education, and it's open and free to use for other purposes as well, in developing economies, and they have an enterprise version that does cost money for business applications. Why are they so generous if they're a company? So most companies are there to make money, aren't they? But RStudio Posit is not a traditional company. They are a society-focused company that places impact on society above profits in a legal framework. So they're a new kind of company, and as far as I know, that the United States is the first place for this kind of company to exist, and Posit are located in the United States. You need help. I've kind of cheekily put links to a Google search for help installing R in Windows, help installing R for Macs, and help installing R for Linux. There are numerous web pages to help you, but of course we will help you in these Herrig meetings if you do need help. Just contact us in Slack. We can hook up anytime and help you. There is a second option, which is quite a nice option, which is RStudio Cloud. The company Posit also has a cloud version of RStudio and R that you can access for free. There are a few restrictions, but it looks the same as the local installation. It is very fast to use, even though they're located in San Francisco. And I presume the servers are located on the West Coast in the United States. All you have to do is sign up. They don't spam your email address. I've been signed up for 10 years or so, and I've never gotten an unsolicited email from them. So they're not going to sell on your email. There's no setup whatsoever. It's a very slick interface. There is a restriction or two that is worth saying. One restriction is that you have free hours for use of an active project while you're signed in, and your free use hours are 25 hours per month. And they have some paid plans, which are reasonable, especially for students. But I think that's a good option if you can't install it on your local computer. This is the basics of the RStudio setup. I'm just going to open up my own RStudio at this juncture to have a look at it. I think I've just reinstalled RStudio myself on this computer to get the newest version. So I'll just open it from the help menu. This looks exactly the same on every computing system. I'm just going to close these scripts and close this project. And just close these scripts. Don't need to save that. There we go. So you first open RStudio, it will probably look like this, where you don't have a script open and there are different panes of windows you're looking at. But the commonest view you'll see once you begin using it is to have a script open, and the script window by default is in the upper left. This is the place. I'm just going to make the text a little bit bigger for everybody to see a bit better. This is the place where you document your commands in the script window, and we'll practice with that in just a moment. In the upper right over here, it says the environment is empty. We don't have anything in memory at the moment, but there's a graphical display of data objects. I call this R space as a metaphor for what is being held in memory. And if you can't see anything, if it's empty, it's like you're floating in space and nothing around you. There's some other tabs up here, which we will possibly talk about in the future. Down here, there are lots of tabs in the lower right. Plots window. We'll make a plot in just a moment to have a peek. There's some other tabs that are useful. So you can navigate your file menu. This is most useful if you use projects. So it might be a bit advanced from the first day. Packages. So packages are toolboxes that you can install, and at the moment there are around 20,000 packages that can be installed. You'll only ever use a few hundred if you're like me. I'm pretty good at using 100 or so R packages and all the tools in the toolboxes. But if you need new ones, and you often will, you'll install them here. There's a help menu, which we will learn to use. There's a viewer that is primarily used if you are viewing HTML pages. And if you make a presentation for some packages, the presentation can be viewed here, or you can make it pop up in a web browser. Down here is the console. If I just bring this out a little bit, we have a welcome screen that states the R version and gives a little bit of other information, but outputs come down in the console. I'm just going to demonstrate a little bit. For example, we can make a variable called X. We'll talk about the syntax of all of these in future meetings, but if I wanted to make a variable called X that was a vector that had different values, let's say it had 3 values in it, and the values were 3, 2, and 4. I could submit this. There are several ways to submit code, either by selecting the code, or having your cursor on the line of the code, and clicking run. But I've done the pop-up tooltip, and we can see that Control plus Enter is the same as hitting that run button, the hotkey. So I'm going to hit Control Enter, 3, 2, 1. You can look down in the console and see what happens down there. So what happened is my command was echoed down here. We know this is echoed because we see the greater than symbol that will be in front of every echo and every output in the console. We also see that the global environment has changed, and now it says we have a value. The value's name is X. We see that it's classed as a numeric. We see that this vector has values 1 to 3. 1:3 implies that's a shorthand for 1, 2, and 3. We see the actual values, at least the first few of them. In this case, there are only 3, 3, 2, and 4. If I wanted to echo the contents of X, I could just select the X variable and submit. Look down in the console, 3, 2, 1. We see the contents of X echoed. So this is just an overview of some of the tools that we use in the boot camp, and we'll practice them in future sessions quite a lot. Now, I practice and teach a very specific workflow for scripts, and the very, very basic elements of setup for a script is that your script contains a header, it contains a contents, and it contains one separate section for each item of contents in your script. And then it's in these sections of contents that you'll actually do an analysis. And by way of looking at this, we'll just look at an example script. What we see here is some syntax. We'll explain elements of the syntax when we start looking at the R scripting language, but for now, we can just think about the hashtag as a way to make a distinction between code that you want the scripting engine in R to evaluate as computer code versus comments that you make to yourself or other people who might reproduce your script. So if we have a hashtag at the beginning of the line, it's a human language comment that we don't intend R to actually run. So we call these commented sections. And I like to have one whole section that is the header section. And what does the header section contain? Well, just right in the very beginning, who, what, and when. So this script is the RStats Bootcamp. What is it? It's a script for the first bootcamp for the setup page, and when it was last edited, in October. A few other things about this section. The syntax, where there is at least one comment hashtag and 4 at the end of a line, is a special way to make a comment that creates a clickable section. So we can see the text between at least 1 and ending in 4 as a clickable section that allows us to click on this and navigate through the script. Actually, there are 2 ways to do that. We can open this little sidebar here, or there's one down at the bottom that we can use to navigate to the clicks. It's up to you. These, just by the way, emulate similar tools in other popular programming languages that are a good idea, and just both of them are preferred by different people. So both of them are implemented in RStudio, like they are in other interfaces for programming languages. The second one that I like to have in is a contents. This one often will have information about setting up a script. And here I just have 2 elements for this first script. One is we're going to look at the iris data, and well, step 0 is look at the iris data, and step 1 is making a simple graph. Okay, so just to see what we can do with the script. If I just close this again so we can see some of the script, section 0, let's look at the iris data. Iris data are called Anderson's iris data, or sometimes called Fisher's iris data, because that guy, R.A. Fisher, used a data set about flowers to illustrate the statistical technique principal component analysis. Okay, so this was also something that R.A. Fisher did. He did many, many things. So what I want to do is, this is a built-in data set into R, and there are a bunch of them that are built in that are used for examples and to illustrate code. And so my comment says here we are telling R we want to use a data set called iris. So we use the data function. We'll talk all about functions in future boot camps. And inside of these brackets, after the name of a function, we can think of a function as a tool. And often we want to give the tool something to work on. And here we're giving it the name of a data set. So when I submit the data function, over in the environment should pop up a data object called iris, or a promise for it. 3, 2, 1. Okay, we see there's a promise. What is happening with that? Well, for built-in data, we haven't actually used the iris data set yet, so this is just reserved a little bit of memory that will be used if we actually use the iris data set. We can print the so-called head of the data, the first 6 lines, just to look at what the data look like if we use the head function, 3, 2, 1, down in the console. So we can see that there are sepal lengths and widths, there are petal lengths and widths, and there are species. Furthermore, up here in the global environment, we can see that there are 150 observations. That means 150 rows of data, and the 5 variables. I happen to know this data set pretty well. There are 3 species of irises, 50 observations each. And if you would like to read about the information about the iris data set, we'll use the shorthand for help, which is the question mark before the function name or object name that we would like help on. The help system is over here, in R. And when we execute this command on line 21, 3, 2, 1, it will pop up with the help page. We'll go through how to read in our help page effectively in a future session, but it is the first stop. Learning to use this help page in R is way more powerful for most applications than Google, but it will seem foreign at first. We have to practice it. And then last, we're going to make a simple box plot with our graph. This calls the box plot tool, box plot function. And inside functions, the information we pass are the names of the information are called arguments. We set them with an equal sign. So the formula argument for our box plot is sepal length as a function of species. And the data set is going to be iris. This should make a box plot down here in the plots tab, which will be automatically selected. I'm going to make it a little bit bigger. And I'm going to execute the code. 3, 2, 1. There we go. We have sepal length on the y-axis, species on the x-axis, and we get our box plot. Now, we are out of time. And as you know, we have the practice of not going over time. I would like to ask if there are any questions or comments. I know this was fast first overview. Plan for this is for future days. I will invite by email people to go through the bootcamp code ahead of time, and we'll spend the time in here. I'll go through a lecture, just the slides to introduce the web page content, and then we'll spend the rest of the time on the exercises. So we'll do that in the coming weeks. There are a few weeks we have off of our schedule, and then we'll resume the boot camp. Another thing will happen about the boot camp, especially since 2 people, and I suspect there are some others, have told me today that they wanted to come but couldn't attend at this time. So we will record these sessions just as usual for the Herrick group, but I will make additional video files just for the lecture content, and also to run the code, and I will put those up on the bootcamp page. Now that will take some months to do that, but it'll be there for people who can't regularly attend these sessions and want a slower pace to dip into this material as they wish. So I'm going to stop the video now. Thank everyone for coming. I have a meeting right after this that I have to scurry off to.